Hey, today's notes are on ocean movements, things you should be able to do by the end of the notes. You'll be able to identify the effects of waves on the shoreline, describe how wind affects ocean water movement, and identify patterns of currents. So types of water movement. There are three general types of ocean water movement. There are waves, surface currents, and deep ocean currents. Each plays a different role in the movement of water in the oceans. Waves. When you go to the beach, the first thing that you usually notice is how windy it is. It's always windy on the beach, or a good portion of the time. Ocean waves are caused by wind. A wave is a visible evidence that energy is passing through the water. There's no better use of a wave than to go surfing or body surfing. Surface currents. Surface currents are movements of water that flow horizontally on the surface of the ocean. Like with waves, the energy that drives surface ocean currents comes from the wind. Friction is also involved in the development of the surface currents. Here is a look at some of the ocean currents of the world. Western drift, the easterlies, we talked about that a little bit. Notice what you notice about the current patterns of the northern hemisphere and then the southern hemisphere. So surface currents, because the Earth's rotation, currents are directed to the right in the northern hemisphere and to the left in the southern hemisphere, around 30 degrees latitude, north or south of the equator. This is because of Coriolis effect. Bottom line, the Coriolis effect causes surface currents to be deflected, depending on which hemisphere they're in. Surface currents. Wind can also cause vertical water movements, like upwelling that we talked about yesterday in class. You did your little activity where you were blowing on the water. Deep ocean currents. You can see where the cold water goes and the warm water goes. This is kind of interesting fact. How long do you think it would take if you dropped some water off the coast of North Carolina to circle all the way around the Earth on the through these surface or these deep water currents? It would take about 2,000 years to do that. That's kind of interesting. That might be a bonus question on a test. So deep ocean currents. Ocean currents that move toward the poles are warm, and ocean currents that move towards the equator are going to be cold. Why is the water moving towards the equator cold? Where does it come from? It becomes cold when the currents move deep underwater because cold water is more dense. And what about the warm water? It warms up when the currents bring it to the surface. So when it gets less dense, it goes to the surface. When it gets more dense, it goes down deeper into the ocean. And that's it for the notes today.